So happy Monday to you. It's day 2, solving rational inequalities. But let's take a minute to look ahead, because worksheets 1 through 3 will be due Friday. We'll do worksheet 2 today, worksheet 3 Tuesday. So that gives you several days to finish everything that's due on Friday. We'll test next week. Next Friday, first quarter review. I probably shouldn't put this on video, but that's ask me questions on the quarter. It's a catch-up day, so if you have a test to make up or something to do, we'll do it that day. But otherwise, there's not a new lesson that day. There's nothing. It's a free day. That's what I'm trying to say. And then we have the next week off, so that's nice. We're almost there. Almost there. All right, let's look at solving inequalities. Inequalities. So let's answer in reverse order here. What is inequalities? What does that bring to your brain when you see the word inequalities? Yes? What was that? You don't want to say it out loud? Someone's back there in the back making the less than and greater than signs? Yes, that's what makes it an inequality. That's supposed to be a comma. The less than or greater than stuff. And then when we solve them, that means our answers are in intervals. And we have to put them on the number line. So we're thinking about open circles versus closed circles. And that kind of leads to parentheses versus brackets. So all of that stuff you kind of know. Maybe you know it really well, but you've certainly seen it before. Give them the benefit of the doubt. All right, so here's the steps that we'll follow today to solve inequalities. Because I don't know that you've solved this type before, so we may do this a little bit different than you've done before. First step will be to find the zeros. And sort of 2 subpoints of that. Find the zeros of the top and bottom, because we'll have a rational expression. So we'll have a numerator and a denominator. You'll need to find the zeros of both. And you'll find them usually by factoring. Because if it doesn't factor, then you get an ugly number, and then you have to put an ugly number on the number line, and then it gets a little ugly after that. So most of the time they'll factor. And in fact, some of the time it's already factored, so that takes some of the work out of it for you. Step number 2, set up the number line with the zeros. Or put the zeros on a number line. Probably should have said it that way. Put the zeros on a number line. And when you put the zeros on a number line, that will set up the intervals, and then we'll test the intervals. Test the intervals to see if one value on the interval works, then they all work. If one value on the interval does not work, then none of them work. So all you need is one value per interval to see if it works. So 2 Roman numerals. Roman numeral 1 has 1 example. Roman numeral 2 has 2 examples. Polynomial inequalities. X cubed minus 6x squared minus 7x is less than or equal to 0. So find the zeros, put them on the number line, test the intervals. Zeros, number line, intervals. So let's factor it. So x cubed, which looks ugly, but we can pull out an x. And then what's left will factor. So there's my zeros. Zero, 7, and -1. Step 2, put those on a number line. And one of my favorite things for people to mess up, one of the dumbest things for people to mess up, is to not put them on in order. Right? The point of a number line is it gets bigger, left to right. So please put your solutions on there in the right order, like least to greatest, left to right. Because if you put them on there out of order, it's going to be really messed up. So -1 is the smallest, and then 0, and then 7. Occasionally, I'm sure it's just an oversight, or they're going fast, or a lot of times what happens is they'll put their number line underneath their zeros, and they'll put their zeros on exactly the order they found them. So they'll just put 0, 7, -1. Come on, pay attention. The spacing doesn't really matter. Like, you don't need to measure out and make sure the scale is right. Like, as long as they're on there in order, that's good enough. Open circles or closed circles for those zeros? Why closed? The equal to sign means we want closed circles. We want to include those spots. Those points make the expression 0, and that's okay because 0 equals 0. So closed circles because of the equal sign. Next, we want to test the intervals. I've got 4 intervals here. 1, 2, 3, 4. So I need to pick a number in each interval to test and see if it works or not. So what's your favorite number less than -1? I'm going to go with -2. Any number less than -1 would work. So -8, -5 million, take your pick. I'm going to go -2. How about a number between -1 and 0? Yeah, -1/2. There aren't any integers there, so you could pick anything you like as long as it's between 0 and -1. How about 0 to 7? I'm going to go with 1. 3 would be fine. 4.375 would be fine. 6.8. But pick something easy. Right. Pi, get creative. And then greater than 7, I'm going to go with 8 instead of asking you for your ludicrous solutions. All right, now those are our test values. We need to test those into, we can either test them in the original, but that would kind of be a pain because I don't really want to cube 1/2 and keep up with signs. So if you test them into the factored form, life gets a little bit easier. I'd say a lot easier. So if I plug in -2 times -9 times -1, and I want to know if that is less than or equal to 0. So it's not really a statement, it's more of a question. So negative times negative times negative is a negative. And I don't really care about the values. So sure, it's 18, but that's not what I care about, only the signs. So negative is less than 0. That's true. And if -2 works, that means everything on that interval will work. So we'll shade that interval. All right, we go to plug in -1/2. I get -1/2 times, well, yes, -7.5, but all I care about is negatives and positives, especially since I'm multiplying. So negative 1/2 minus 7 is negative. How's that for lazy math? But that's all I'm concerned about. Negative 1/2 plus 1, what's that equal to in our lazy math? What's negative 1/2 plus 1? Positive. And we want to know if that is less than or equal to 0. Well, the numbers don't really matter, only the signs do. Negative times positive would be a positive. Positive number greater than 0, that's not true. So we will not shade that region. Things usually get easier as you go left to right because you jump from the negatives to the positives and you're less likely to make a mistake. If I plug in 1, I get positive times 1 minus 7 is negative. 1 plus 1 is positive. So that's a negative number less than or equal to 0. That's true. So we'll shade everybody from 0 to 7. And then we test 8. Again, if you test it in the original, you got to do 8 cubed minus 6 times 8 squared minus 7 times 8. If you test it in the factored form, you're just looking at positive times positive times positive. Positive number less than 0, that's not true. So there's the picture of our answer. We usually want our answer in interval notation, so we sort of read our number line left to right and say the solutions go from negative infinity to negative 1 with a bracket, and then 0 to 7 with brackets because we want to include all of those zeros. Find the zeros, put them on a number line, test the intervals. That was the easy one though, because that was a polynomial as opposed to Roman numeral 2, rational inequalities. Ratio inequalities. So fractions. Three x minus 7 over 2x plus 6 greater than or equal to 0. Well, zeros at the top, zeros at the bottom. Put them on a number line, test the intervals. So from the top, 3x minus 7 equals 0. That would be 7/3. That's not the greatest number in the world to mess with. From the bottom, 2x plus 6 equals 0. So x equals negative 3. So those are my zeros. I'll put those on the number line. And even if you're not great with what 7/3 is, it's positive and 3 is negative, so I can locate those easy enough. Be careful, don't race in front of me here because open circles or closed circles for those. Yeah, you'd think that. You'd think that. 7/3 is closed. I'm good with that one. But why not negative 3? What is going on with negative 3 that it's an open circle? Denominator can't be 0. You can't divide by 0. Denominator can't be 0. And so for the bottom, in fact, some people will write it like that from the get-go. 2x plus 6 can't be 0. X can't be negative 3. And so the bottom is always an open circle. before inequalities come into play, you can't divide by 0. So zeros of the denominator, always, always, always an open circle. Numerator, it depends on whether the equal sign is there or not. So this one we've got one open and one closed. All right, let's pick our favorite value less than -3. How about your favorite number between -3 and 7/3? 1 would work. 0 is probably easier. And then we've got to be a little bit careful here. What's a number bigger than 7/3? 3. 3 is the smallest integer bigger than 7/3. If your fractions were, extra weak, then you can pick 100 and just make sure you're out there. But 3 is probably the best pick. So plug in -4. Again, I'm really only concerned about positives and negatives. So 3 times -4 minus 7 is negative. Negative what? I don't care. Negative. 2 times -4 plus 6. That one's a little closer. So -8 plus 6 is still negative. And we're trying to see if that's greater than 0. But a positive number greater than 0, yes, that's true. So that works. 0 is really easy to check because 0 wipes out the x's. -7/6 greater than or equal to 0. That's not true. So we don't shade that region. Officially you don't need to put an x there, but the x there sort of reminds me that I've checked it and it doesn't work, as opposed to just leaving it blank. I plug in 3. 9 minus 7 is 2. 6 plus 6 is 12. Sort of switch back to actually finding the numbers, although I didn't need to. Positive number greater than 0, that's true. So we'll shade over there. Then we just need to be careful with the interval, because we got one open circle and one closed circle. -∞ to -3. Parentheses. Right, open circle leads to parentheses. Union with bracket 7/3 to infinity. Okay, there's a shortcut kind of in the background that will help us if we can recognize what it is and know what the limitations are. So look at the two pictures. Sort of zoom out your focus, and I will literally zoom out the camera here. Look at those two pictures of the number lines and tell me if you think you see a pattern. Again, it's only two pictures, so it's hard to make any conclusions when you've only done two of these. Think about as you move left to right, what does the shading do? Be careful with there's no middle. So this one had two middles, so I wouldn't say there's no middle. Every other. Every other is the shortcut. It alternates. Which means, well, you tell me what's that mean. If it alternates, how could that save you time?
You just have to know the first problem and then just do the pattern.
Yeah, you just need to know one interval. And in fact, it really doesn't even need to be the first one. You can pick whichever interval you like, whichever one seems easiest to you, like maybe the 0 or maybe an 8, but whatever interval seems easiest, pick that one and then alternate after that. 2 words of warning. One is probably wise to check 2 intervals just to confirm the alternating thing. So check 2 and then alternate. The other thing is there's one time where the alternating rule doesn't work. So if you're going to use the shortcut, you better know when it doesn't work. And it doesn't work when there's a double root. And that might make sense. A double root would mean that a graph bounces instead of crosses. And so if it's positive on one side, it would be positive on the other side. Or if it's negative on one side, it'd be negative on the other side. So use the shortcut, but know that for double roots, you better slow it down, and I would just check all the intervals for double roots. Although the alternating still works, it just doesn't alternate across a double root. All right, we'll use that shortcut on this one and save ourselves a little bit of time. And I guess like most shortcuts, if you don't like it or don't want to use it, that's fine. You'll just have to go take a little bit longer to get there. All right, 3 over x minus 2 greater than or equal to 2 over x plus 1. Find the zeros, put them on the number line, test the intervals. Well, 2 of the zeros are obvious, like 2 and negative 1. That's fine, and those will be part of our answers. But if I want to find the zeros, what do I have to do first? Thought you were right the first time. Yeah, I thought you would give me an answer. When we say find the zeros, that means set the thing equal to 0 and figure out what makes it 0. So let's subtract over, and I'm going to leave some space because I'll need common denominators to make this work. So I'm going to make it equal to 0, then I can find the zeros. So this is a problem from Friday. First term needs an x plus 1. But then the second kid is like, wait a minute, that's not fair. I want an x minus 2. So that's 3x plus 3 minus 2x, careful, plus 4. I'm going to be lazy and not write the denominator. X plus 7 over x minus 2, x plus 1. Okay, so that took a little bit of work, but now it's pretty obvious the zeros of the top and the zeros of the bottom. In fact, I don't need to write down the factors equal to 0. I can just, it's already factored. For the bottom, maybe to remind myself, I'm going to say x can't be 2 and x can't be negative 1 because those would make the bottom 0. Okay, again, please put them on in order. Someone's going to do it, and they'll be so frustrated when they get their test back. And I've made some snarky remark about number lines. Negative 7, is that an open circle or a closed circle? Closed, because it was the equal sign and it came from the top, so closed for negative 7. What about negative 1? Open, and 2? Open because it came from the bottom. All right. Well, is this eligible for the shortcut, the alternating rule? Like, I don't know. We just learned the alternating rule. I don't know. When's the only time it doesn't work? Double roots. Are there any double roots? How would you know? Like, what are we looking for? What would a double root look like? A squared. If a factor is squared, that makes it a double root. I don't have any of those, so I can use the alternating rule. So I don't have to test all of those. If I was really pushed for time, I would only check 0 and alternate after that. If I had a little bit more time, I might check two of them to make sure that things look right. So I'm going to check 0 and 3.
What about like triple roots?
So triple roots, that's a good question. A triple root crosses rather than bounces. So a triple root would alternate because it alternates signs. So a triple root would alternate. A quadruple root would not alternate, and so on. So it's back to that even-odd root thing. All right, I'm going to plug in 0, and I'm going to plug it into the factored form because that's usually the easiest way to go. So that's 7 over negative 2 times 1. Let's see, that would be negative greater than 0. No, that's not true. Again, push for time, or I've got the answers pulled up on the computer because I'm working at home, then maybe I just alternate and check the answers. Or push for time on test. If I got a little extra time, maybe I check 3 to make sure. Let's see, 3 plus 7 is 10. 3 minus 2 is 1. 3 plus 1 is 4. Again, I don't really care about the values. All that's positive. Positive is greater than 0. That interval works as we thought it would based on alternating. So that means this one should work, and that last one should not work. And I'm good with that. You do not have to check every single interval. You can use the alternating rule. That is completely okay. If it's a hard one or you're not sure, you got extra time, by all means, check as many as you like, but you can also just use the alternating rule. And then be careful with parentheses and brackets. All right, today's assignment is worksheet 2, which I'll give you in a moment, and then we'll actually do number 3 together. Or no, write it in inequality notation. So if I want the zeros of that thing, I need to make it equal to 0. I need 0 on one side or the other. So I kind of have an option here. Do you want to move x to the 4th over, or do you want to move 10x squared minus 9 over?
10x squared minus 9.
I think I agree with you. That way our x to the 4th stays positive. The trouble, I guess it's not trouble, the trick we need to be careful is that it feels like this is on the side opposite of what it usually is. So you can either just deal with it as it is, or you could rewrite this inequality x to the 4th minus 10x squared plus 9. How does that compare to 0? That means it's greater than 0. So you can just deal with it, or you can switch it around. I'd switch it around just because, I don't know, I want it to look like I think it should look. That's probably the hardest part of this problem, is getting it equal to 0 and then kind of switching things around so that it looks right. Let's see, we factored ones like this before with x to the 4th in there. X squared minus 9. I'm running out of space. I'm just going to go ahead and say x equals plus or minus 3 and x equals plus or minus 1. So on a number line, again, please make sure you put them on in the right spot. Open circles or closed circles? All closed. Although if you look at your answer choices, they all include the equal sign, so you wouldn't really be worried about that. How many intervals is that? 5. How many intervals do you want to test? 1, that's right. So let's test 0, and then we'll alternate from there. So I've got a couple options. I can test it in, well, I got 4 options, I guess. I can test it into the original. I can test it into this factored form. I could have factored it one more and tested it into there. I think I'm going to test it into here. So negative 9 times negative 1 is a positive. So positive greater than or equal to 0. That's true. So I do want to shade that. Were there any double roots in this? No, like it's maybe tricky, but plus or minus 3, that's not a double root. That's 2 separate roots. Plus or minus 1, that's not a double root, that's 2 separate roots. So I'm okay to alternate. And then I just look at my answer choices and see which one matches. And it looks like C matches. The main point of that one was it's set up a little bit weird, and you have to be careful getting it to sort of normal before you work the rest of the problem. One more comment, and then I'll be done. Look on the back and find me a problem where you're going to have to think about double roots. Find me a problem on the back where double roots are going to be an issue. 7 and 8. Because 7's got a squared and 8's got a squared. Both of them are already factored, so that makes life a little bit easier. But it's not going to alternate across a double root. So be careful on 7 and 8. All right, again, this will be due Friday. Test is next week, and then the next week we're off.